Hello everybody, my name is Kiran. I am working as an assistant professor in the department of EEE Anits. I welcome you all to my series of lectures on the concept of network topology. In my previous lecture, I have discussed various basic terminologies that are associated with network topology. I have also discussed the procedure to construct incidence matrix for a given circuit or a graph. In today's lecture, we are going to see the procedure of how to construct a tie set matrix. First, what is a tie set? A tie set of a graph is nothing but a loop that is formed by one link which is associated with many twigs. So, which means that in order to form a tie set, we should have only one link, but it can have any number of twigs. So every link of a tree corresponds a loop, and number of loops is equal to the number of links of a tree, and number of tie sets is equal to the number of links of a given tree. So depending upon the number of links that are present for a given graph or a given tree, we can decide how many tie sets can be formed. So the order of the tie set matrix is L cross B, where L is the number of links and B is the number of branches. The procedure to construct tie set matrix is, first we have to assign nodes and branches and then draw the graph for that particular network, and after that we have to make that graph as a oriented graphs by giving some arbitrary direction in each branch. Then a suitable tree should be selected containing n-1 branches, and using that condition, that is, a tie set is formed when we consider only one link and any number of twigs. So we will form, using that constraint, the number of tie sets for the given graph. And the closed loop current direction should be assumed as the same direction of link. If it has same direction, then we'll enter +1. If the direction are opposite to one another, then we'll consider as -1. If there is no relation between these two, then we enter as 0. So let us consider one example. So here we have to obtain a fundamental tie set matrix. I have chosen 5, 6 twigs as a tree. So we know that what is the condition for forming a tree. Okay, it should not have any closed loop, but should consist of all the nodes. So you have 3 nodes here, 6 branches. So the number of twigs will be n-, that is 2, and links L is equal to B minus n plus 1 is equal to 4. So you can see, according to the formula, everything is perfect. And so since we have the number of links as 4, the number of tie sets will be also 4. So as I told you, what is the rule to form a tie set? It should contain only one link. It can contain any number of twigs. So this is one tie set. So it has only one link and one twig. That's fine. This is my second tie set. So it is also have one link and one twig, so that's also fine. This is the third tie set of the given graph. So I have only one link, I have 2 twigs, so the condition is met. It should always have only one link. Okay. Next, if I see clearly here, I have 2 links and 1 twig, but according to my rule, in order to form a tie set, it should only contain one link. It should not have more than one link. So this cannot be treated as tie set. Coming to the next possible tree, here also I have one link and 2 twigs. So the condition is met. Here if I see, I have 2 links and 1 twig. So this I cannot consider as tie set. And next, so here all branches are links only, there are no twigs, so this also cannot be considered for formation of tie sets. So as seen previously, a number of tie sets will be 4 depending upon number of links. So we have got all the 4 tie sets. Now we should construct the tie set matrix, and remember the loop direction that is indicated as loop direction, which is indicated in green color, should be in the same direction as the link direction. So using this, now we'll try to form the tie set matrix. While forming tie set matrix, remember first link should be entered, then twigs should be entered. Here the links are 1 2 3 4 and twigs are 5 and 6. So whatever order is being followed here, the same order should be followed here also. Okay, since I have first link entered here, what is the tie set corresponding to first link? That is 156. Next entry is second link, the tie set corresponding to second link is 25. This is the third link, the tie set corresponding to third link is 36, and next is the fourth link tie set corresponding to fourth link is 456. So whatever order you are following in the entry of links, the same order should be followed for tie sets. Okay, so let us consider first tie set. So here the direction is in the same direction, the loop direction and the link direction are same, so you'll get +1. Second branch, third branch, fourth branch are not at all involved in this tie set, so 0. The fifth twig is in the same direction as the loop direction, so +1. Sixth twig is in the same direction as loop, so it is +1. Now considering the second tie set, the first link is nowhere related to this tie set, so it is 0. The second link is in the same direction as the loop direction, so +1. 3 and 4 are nowhere related to this tie set, so it is 0. Fifth twig is in the opposite direction of the loop direction, so it is -1. And sixth twig is nowhere related to this tie set. Now coming to my third tie set, 1 and 2 are nowhere related to this tie set, so it is 0. Third link is in the same direction as loop direction, so +1. Fourth link is nowhere related, so 0. Fifth twig is also nowhere related to this tie set, so it is 0. The sixth twig is in the opposite direction of the loop direction, so it is -1. And lastly, the fourth tie set, 1 2 and 3 are links are nowhere related to this tie set, so they are 0. Fourth link direction is same as the direction of loop, so +1. Fifth twig as well as sixth twig both are in the same direction as the loop direction, so it is +1. So this is how we form a tie set matrix for a given graph. Coming to my next example, here also I need to construct a tie set matrix. So first I will find the graph. We know how to form a graph, replacing every element with a line segment and assigning some arbitrary direction will give you an oriented graph. So this network, and if I have a voltage source, I should replace them by short circuit. If I have any current source, I should replace that by open circuit. So doing so, I will get that oriented graph as shown in the right side corner. So in this oriented graph, I have considered 1 2 3 branches as my tree, and the remaining branches obviously will act as links. So here, since I have 3 links, So the number of tie sets will be 3. So using this, so you can see, as I told you, while forming tie sets, it should contain only one link, and it can contain any number of twigs. Okay, so while forming tie set, be careful that it should have only one link. I'll consider one link at a time. So first I consider fourth link, and you should see to this fourth link what are the twigs that I can add to form a closed path. So 1 and 3, if I add to this link, you will get a closed path, so that we can form as a tie set. The second link, fifth link, I have considered, and if I add twigs 2 and 3, they form another tie set. And lastly, sixth link I have considered, and if I add 1 and 2 twigs to this link, it forms another tie set. So this is how I can form a tie set depending upon the number of links, and the loop direction will be same as the link direction. So on construction of tie set matrix, since here the links are 4, 5, 6, first I need to enter 4, 5, 6 and then 1, 2, 3. This order is very important. First I should enter links, then I should enter twigs in order to form tie set matrix. And you can see clearly, since the order is 4, 5, 6, the tie set related to fourth link is 4, 1, 3, the tie set related to fifth link is 5, 3, 2, and the tie set related to sixth link is 6, 2, 1. So now if it has same direction, it is +1. If it has opposite direction, -1. If they have no relation, 0. So my fourth link is in same direction as the loop direction, so +1. 5 and 6 links are nowhere related, so it is 0. First twig is in the same direction, so it is +1. Second twig is nowhere related, 0. And my third twig is in opposite direction as the loop direction, so it is -1. Coming to my second tie set, that is 5, 3, 2. This is over. This is the first I have considered. The second one, 4 is nowhere related to my second tie set, so it is 0. The fifth link is in the same direction as the tie set, so it is +1. Sixth link is nowhere related to this tie set, so is 0. First twig is nowhere related to this tie set, it is 0. Second twig is in the same direction as the loop direction, so it is +1. And third twig is also in the same direction as the loop direction, so it is +1. Now considering the last tie set, 4, 5 is nowhere related, 4, 5 links are nowhere related to my third tie set, so it is 0. Sixth link is in the same direction as the tie set, so it is +1. First twig is in the opposite direction, so -1. Second twig is also in the opposite direction to my loop direction, so it is -1. And third one is nowhere related to my third tie set, so it is 0. Coming to my next example, is given oriented graph is given. We need to find the fundamental tie set matrix. So here also I'll consider 1, 2, 3, 4 branches as the tree branches, and the remaining branches will serve as links. Since I have 3 links here, a number of tie sets will be 3. So every link I'll consider and see what are the twigs that I can add in order to form a tie set. So here I have considered 7th link, and when adding 4, 1, 3 twigs, I can form one tie set. Here I have considered 5th link, and upon adding 1 and 2 twigs to that link, will form another tie set. And 6th link I have considered, and upon adding 2, 1, 4 twigs, I can form another tie set. So the loop direction has been considered the same direction as the link direction. So first we'll enter the links 5, 6, 7 and later the twigs 1, 2, 3 and 4, and correspondingly we will enter the tie sets according to the order of the links. So first fifth link is in the same direction as loop direction, so it is +1. 6 and 7 are nowhere related to the first tie set, so it is 0. First twig is in the opposite direction, -1. Second is the same direction, +1. 3, 4 is nowhere related, 0. So now I'll consider my second tie set. This is the second tie set. 5 is nowhere related, 0. 6 is in the same direction, +1. 7 is nowhere related, 0. 1 is in the opposite direction, -1. 2 is the same direction, +1. 3 is nowhere related, 0. 4 is in the opposite direction, -1. So next the third tie set. 5 is nowhere related, 6 is also nowhere related, so both are entered 0. 7 is in the same direction as the loop direction, +1. 1 is in opposite direction, -1. 2 is nowhere related, 0. 3 is in the same direction, +1. 4 is in the opposite direction, -1. So this is how we have found the tie set matrix for all the given graphs as well as networks. So this concludes my today's lecture on the concept of tie set matrix. So in the next lecture we are going to see the concept of cut set matrix. Thank you.